We're going to start off with problem number 2, and the first thing we have to do is look at what z of x is equal to. We're going to come up with the exponential function that shows this log function here. Alright, so starting off with the exponential equation, we say that 2 to the z of x power, which is y, is equal to x. And so what I did is I plugged in y values to come up with my x values, which describes this t-chart here. And then furthermore, I've plotted those points to make the logarithmic graph. Down below, we have the limit as x goes to 0 from the right side, the y value goes to negative infinity. That represents a vertical asymptote. You guys good there so far? Okay. So thinking about what this equation is going to give us, first of all, we have a plus 3 and a minus x. It might make more sense for you if you were to flip that around and look at it that way. A plus 3 means that we have a horizontal shift to the left 3 units. A negative x means a reflection over the y-axis. So that sort of helps us understand what we should be looking at. So a horizontal shift to the left and then a flip is going to give us something like this here. Okay? But let's go ahead and figure out exactly how that should look, because that's the expectation. But remember that you guys can rewrite this even in terms of an exponential equation. And I could say that 2 to the p of x power is equal to 3 minus x, right? And so we could solve for x and say 2 to the y power minus 3 negative in front is equal to x, right? So that's another way of checking our answer. Okay, let's go ahead and come up with the table of values. What I'm going to do here is I'm going to come up with the table of values based off of the transformation and transform these x values and keep these y values the same. You see, the only change I really have to be concerned with right now, going from the base to the transformation, are my x values here. And we have a horizontal shift to the left by 3, right? So that means that we're going to subtract 3 on our original x value. So we're going to take that original x value, and we're going to subtract 3. And then after that, we have a reflection over the y-axis, which changes our x values, right? We change the sign of the x values, so we're going to multiply by a negative as well. So let's come up with some points that describe this. If I were to plug in 1/4 into this x spot, I would have 1/4 minus 3, which is negative 2.75. Times a negative gives me a positive 2.75. And we're going to keep that same y value. If I plug in a 1/2 into that x spot, 1/2 minus 3 is a negative 2.5 times a negative is a positive 2.5 with that same y value. Okay, so plugging in a 1 into that x spot gives us a negative 2. Negative 2 times a negative is a positive 2, keeping that same y value. Plugging a 2 into the x spot here. 2 minus 3 is equal to negative 1 times negative is equal to a positive 1. And then we have 1 there. Alright, so now we have 4 going in this spot. 4 minus 3 is a positive 1 times a negative is going to give us a negative 1 with that same y value there. So let's go ahead and plot those points and see what the graph looks like. So here we have our transformed graph, and all I've done is plotted the points there. And note here that at the bottom we have the limit as x goes to 3 from the left. Our y value goes down to negative infinity. We have a vertical asymptote at positive 3. So it's important when you're drawing this graph to not cross that boundary of positive 3 there. So what I've done, you guys, is I've transformed my original points, right? I haven't even used this equation, but I can plug in some y values to make sure that I absolutely am correct. You guys with me on that? Does that make sense to everybody? Any questions? Should we move on to the next one? Alright, so moving backwards to problem number 1, we're going to look at transforming our base function into -2 times log base 2 of x. Well, the 2 is going to stretch the function out. The negative is going to reflect your graph over the x-axis. So just kind of having an understanding of what we should look like, that's it, right? Reflection and a stretch. So what we're going to do is figure out exact points to plot here. And in this case, we aren't horizontally shifting, we aren't reflecting over the y-axis, so we don't have to worry about transforming these x points here. Let's just worry about transforming the y points. So when x is 1/4, our y value, we're going to multiply that -2 times a -2 and end up with a +4. And then we're going to multiply -1 times a -2, and that gives us a +2. And then multiply 0 by a -2, that doesn't change. And then we multiply 1 times a -2, that gives us a -2. And then multiply 2 times a -2, that gives us a -4. Let's go ahead and plot these points. Alright, here we have our transformed graph with the limit shown. Kira asked a good question. She said, why aren't we looking at the exponential equation? Well, that definitely still applies. And you can rewrite this logarithmic equation in terms of an exponential equation to further make sure that you're right. All we've done is we've used the original base graph to come up with transformed points. But you can still look at changing the logarithmic equation in terms of an exponential equation and plug in y values and get x values to further confirm your result. And in order to do that, for this particular g of x function, we would start this off by multiplying both sides by -1/2, and then we could rewrite our logarithmic equation in terms of an exponential that says 2 to the y over -2, or we could just write -y/2 like so, is equal to x. So you can pick y values and come up with x values to further confirm what you have found. You with me on that? Okay. And so, as I was saying earlier, that's one thing that makes this a little bit difficult, is you can think about this in terms of changing a base function, transforming, or you can come up with a brand new equation and plug in points. Alright? You guys with me on that? Should we move on? Alright, so let's go ahead and talk about problem 3. I've started us off by coming up with the table of values to represent 2 to the x, which is our base function. And from here, let's go ahead and transform the points that I have into the new table of values. So we have to understand transformations pretty well. X minus 3 in the numerator there gives us a horizontal shift, and that's going to shift us to the right, right? So we're going to take our original x value and we're going to add 3. Okay, it's a horizontal shift to the right. Also, we have that plus 3. What does the plus 3 do? That's going to be a vertical shift up. And so we're going to take our original y value and we're going to add 3 onto it. So let's come up with the new table of values here. We have a minus 2 plus 3. That gives us a 1. And then a 3 plus 1/4. That's 3.25, right? And then we have a minus 1 plus 3. That gives us a 2. And then a 1/2 plus 3 gives us a 3.5. And then we have a 0 plus 3 is 3. 1 plus 3 gives us 4. And then 1 plus 3 is 4. And 2 plus 3 is 5. And then 2 plus 3 is 5. And then 4 plus 3 is 7. Let's go ahead and plot these points here. Alright, so we see that our function has horizontally shifted to the right 3, and it's vertically shifted up 3. Our original function, our base function, as the limit of x goes to negative infinity. What's your y value going to? Closer and closer and closer for the original. What's that j of x function going closer to? As our x value goes to negative infinity, y goes to 0, right? That's a horizontal asymptote right there at 0. We have a vertical shift up by 3. So that's going to help us understand the limit here as x goes to negative infinity. The limit as x goes to negative infinity for our transform function, what does s of x go to? It goes to 3. And we know that because we have a vertical shift up by 3. Okay? Alright, so for problem number 4, we have our base function here. And right here, the negative in front of the 2 to the negative x tells us that we have a reflection over the x-axis. And the negative in front of the x tells us that we have a reflection over the y-axis. So we're seeing a reflection over x and a reflection over y. So a reflection over x and then a reflection over y. So we're going to end up with a function like so. Okay? But let's go ahead and come up with some exact values to represent here. So we're going to take our original x value and multiply by a negative. And we're going to take our original y value and multiply it by a negative. Okay? So we have a positive 2 here and then a negative 1/4. We have a positive 1 and a negative 1/2. We have a 0 and a negative 1. We have a negative 1 and a negative 2. We have a negative 2 and a negative 4. Let's go ahead and plot those points. Okay, so here we have our plotted points, and then we have the limit as x goes to infinity. Our y value goes to, not infinity, 0. So remember that these functions here, you can always plug in x values and get your y values also, right? We looked at just transforming our base points, but we can plug in x values to and get our y values to be absolutely certain, right? Move on. Okay, so let's talk about number 10 here. We want to figure out what this is equal to. And so first thing I'm going to do is I'm going to set this equal to question mark. I don't know what it's equal to. I want to figure out what it's equal to. So we say that 6 to some power is equal to 1 over the 5th root of 36. So what I want to do is I want to change the right side so that I have a base of 6. So let's go ahead and press pause. First we write with a fraction exponent. Now we're going to change the 36 into a base of 6 to the second. Alright, so now we have 6 to the second to the 1/5. And we have 6 to the 2/5 down in the denominator, and so that gives us 6 to some power equals 6 to the negative 2/5 if we cross the line, change the sign. So that means that our answer is a negative 2/5. Come by and ask more questions.